In this video we're going to calculate the surface area to volume ratio. So this is primarily important in biology, where we look at the importance of surface area to volume ratio. It's why you see in colder areas there are larger animals like polar bears or whales, polar bears in the Arctic or whales in the deep ocean. It's also why the microvilli in the intestines has a large surface area for absorption of nutrients. So we're going to do some calculations. So we're going to calculate the surface area to volume ratio of these shapes to compare the difference. So we have a 2 by 2 by 6 cuboid. The surface area is 2 times 2, so we have two sides. So we have 4, taking into account this back wall. We have 4, 4, 4 plus 4, 2 times 6, so taking into account this larger rectangle, 1, 2, 3, 4, plus 4 times 12, which is 2 times 6. So that's the surface area. Calculate surface area, it's 4 plus 4 plus 4 times 12, which is 56. When we calculate the volume, it is base times height times length, so 2 by 2 times 6. So that equals 24. So for the surface area to volume ratio, and of course we can divide both of them by 8. So we have 3, and 56 divided by 8 is 7. So the surface area to volume ratio is 7 to 3. If we look at this cube, it has sides 2 by 2 by 2. We compare with the cuboid, so we have to calculate the surface area. So 2 times 2, and we have 6 sides taken into account on the other side of the page. So 1, 2, 3, 4, 5, 6. So 2 squared times 6. That gives us a surface area of 24. The volume is 2 cubed 2 by 2 by 2, which gives us a volume of 8. So our surface area to volume ratio is 24 to 8. Dividing both sides by 8, we have 1 to 3. Just for the sake of comparison, let's divide both sides on this side by 3. So you have 2.3. So when we say larger surface area to volume ratio, this cube has a larger surface area to volume ratio compared to this cuboid. So the microvilli in your intestines has a large surface area to volume ratio. A massive whale in the ocean has a smaller surface area to volume ratio. These are usually adaptations to conserve heat, energy, for example. So if we do some more examples. So we have a cube here. This looks like a Rubik's Cube, where we have blocks of 1 compared to a 1 block of 1. So we have a 9 by 9 and a 1 by 1. So if we calculate the surface area, we have 3 by 3, so 3 squared, and we have 6 sides. So 3 squared times 6 is 54. For our volume, we have 3 by 3 by 3. So 3 cubed, which is 27. So our surface area to volume ratio is 54 to 27. If you divide both by 9, you'll get 3 to 6. And of course, divide both by 3, you get 2 to 1. So if we compare it to a 1 by 1 block as opposed to a 3 by 3 block made up of loads of 1s, so we have the surface area is 1 squared times 6 because we have 6 sides in a cube, and volume is 1 cubed because it's 1 by 1 by 1. Our surface area to volume ratio is 6 to 1. So see the smaller block has a larger surface area to volume ratio compared to this larger block, which has a smaller surface area to volume ratio. And that's it. That's comparing surface area to volume ratio for different sizes.